Okay, welcome everyone to lecture number 7, Spatial Analysis with Rasters. Okay, so this lecture we are going to learn spatial analysis methods that specifically applied to our raster data layers. Before we get started, I want to remind you our raster data structure. Okay, so the basic unit for any raster, as you know, is cell or grid. So basically think about our raster data layer like a giant fish net. Okay, we have a lot of squares that in this raster, and each square or each unit, each cell can only have one value. Here on the right side, I'm showing you the elevation of LA County. Okay, if you zoom in, you will see it's pixelized. Okay, and for each pixel, you will have the elevation for that location. Raster data is especially suited to represent geographic phenomena that vary continuously over the space. So when you download raster data layer, you will see raster data layer for elevation, raster data for slope, temperature, and etc. Raster is very good for spatial analysis actually, because basically when we do overlay, for example, we just simply combine the values in the corresponding cells. Okay, that corresponds to the same location on the Earth surface. Where you can download those data? Well, if you need climate data like temperature, precipitation, air pressure, and so on, you can go to those two websites. If you want to anything about our Earth surface, okay, for example, elevation, for example, aerial photo, satellite image, or land cover, you can actually go to the national map, the viewer, and you can download from there. Okay, in our virtual lecture, I'm going to show you in live. Like our vector spatial analysis, you do have a few group of spatial operators that commonly used. So for example, reclassification, overlay, proximity, and connectivity, and also you can characterizing neighbors, okay, assign a new value to your target pixel, okay, based on the neighboring information. So let me show you several diagrams here to show you the basic idea, and in our virtual lecture, I'm going to show you with examples, okay? So first is the raster reclassification. So for example, the idea is you take the original raster data layer. You also need to define this lookup table, or we call that reclassification table. You're grouping the old values and assign a new value to all the pixels within this range. So for example, 1 to 3, you will reassign the value to those pixels as 5, as you can see here. Okay, and and 3 to 7, see, this is 7. I'm going to assign that as 3, right? So this is another example. For example, this elevation, right? Lower elevation from this number to this number. I'm going to have a new value, number 1. Okay, and number 2, number 5, number 3, and so on. So at the end of the day, all the pixels, okay, you have in this raster data layer will only have 5 values because you have reclassified it. Okay. All right. So then, when we do the spatial overlay and do raster data analysis, raster data spatial analysis, actually like our vectors, you need to think about your scope. Okay, we can just combine single cells that corresponds with the same location on their surface, like in this way. Okay, like your skewer, right? Okay, you can just connect them together, okay, by using certain functions. Okay, we call that single cell function. Or you can define a focal or local function. Okay, basically it's within a neighborhood. We also call this analysis, this function called moving window. So think about it's like a moving window. You covered it at the center, that is your target. You're going to combine all the neighboring information and assign a new value to the target pixel over here. Okay, and you can also have a zonal function. Zonal function is very similar to neighborhood function. okay, or local focal function. It's just your neighborhood or your moving window is irregular. It's just certain zones like zip code zone, like watershed. Okay, and global function, like the name tells you, you take the entire raster data layer and somehow calculate the values within your layer and assign a new value to your target pixel. Okay, so let's take a look at a few examples. So single cell functions, okay, commonly used operator is called map algebra. So it's a cell-by-cell combination. So basically, for example, here, okay, I'm going to combine the cells that corresponds with the same location on their surface. I'm just looking at this single cell. I'm just looking at this single cell. I'm just looking at this single cell. Okay, you can do based on the single cell, you can do what? You can do algebra. So that's why we call that algebra. So what is algebra? Plus, minus, multiply, divide, many others, right? So here you can check it out. Check this link out. It's on ArcGIS online document. Okay, you will have a lot of algebra you can use. For example, the idea is I'm applying, for example, I'm using the multiply. I want to multiply each cell with 2. So you can see it's based on single cell. So I'm going to go through all these pixels, multiply each value by 2. So 2 times 5 equals to 10, 2 times 7 equals to 14, and so on. Okay, another example, algebra function is minus. You're going to take rainfall in 1998 minus 1992, same location, right? And you get the change. Okay, you can also combine like plus. Here, my fire hazard. Okay, for this one is number 1. Okay, for flood hazard. Okay, it's number 2. Okay, combine them together. The hazard risk for this specific location is 3. Okay, here this condition, this algebra function is a little bit complicated. It's called condition. So you should read this formula like this. So condition, okay, condition is my layer A. Okay, so for each cell in layer A, I'm going to look at whether that value is smaller than 3. Okay, if it is true, this condition is true, you take the value in layer B, but at the same location. Okay, otherwise you take the value in layer C at the same location. So you can see the first one, my layer A, this pixel, the value is 1. Okay, it's smaller than 3, yes. So I'm going to take the value from layer B, it's an X. Okay, so the next one is 3. 3 is not smaller than 3, so no. But then I will take this value and as my output at the same location, and so on. Okay, so you can see this is a cell-by-cell combination. Okay, and your local or focal function is a spatial function that computes an output value of each cell using the neighborhood values. So think about it as a moving window. Okay, this window is used to define your neighborhood. Okay, and at the center of that window, that's your target pixel. So you can see here, I'm going to say combine all the values covered by this window. Okay, calculate an average, for example, and assign a new value to this target window. Then I'm going to slide my window to the next pixel right here. I'm going to do the same thing. Okay, so this local or focal function, you will use a lot. Okay, when you process the remote sensing, the satellite image. So for example, there's the window focal function called low pass filter. Okay, so this low pass filter is very good at removing your noises, your outliers. So for example, in this example, you have all the pixels with 5, which is right, but you do have this one is an outlier. Okay, it's a noise, it's a spike. Okay, so you want to smooth that out. You actually can define a low pass filter. Okay, like 3 by 3 window, cover the entire thing, entire area 3 by 3, and your target is this outlier, right? Okay, so let's use mean. Okay, you take all the 9 values, calculate the average. Okay, you can see all the values will become 5.4. Okay, so you can see here through this low pass filter, you can smooth out this outlier, this spike. Okay, so here on the other side, upper side is this high pass filter, emphasize the changes. So for example, here you have all this area as 5, but this specific location is 9. You can define a high pass filter to emphasize, oh, this is my boundary. This is my boundary, and other places will become 0. Okay, so how to design those high pass filter or low pass filter is out of the scope of this class. Okay, you will, if you are interested, check out our introduction to remote sensing, and Professor Mason will introduce this to you. Okay, and in addition to high pass, low pass, a little bit complicated, you can define simple moving window or focal local function to apply that to your raster. For example, you can define the median, so it means I'm going to calculate the average, okay, covered by this window, median, right? Okay, calculate the average of all these values and assign the new value, the average of all the 9 pixels to the target pixel, or median, or minimum, and so on. Okay, but here I want you to get the basic idea of this local or focal function, what we call that moving window function. Zonal function is very similar to our moving window function or local focal function. The only difference is you don't have a regular shape, the moving window. You have irregular zones. So those zones can be, watersheds, or can be your land use types, can be your zip code. When you define those zones, you are going to calculate, for example, median or minimum or maximum of all the values within the same zone. Okay, so for example, this is zone 1. I'm going to calculate, say, average, okay, within zone 1. Okay, looking at those pixels that within zone 1, I'm going to calculate the average. And zone 2, do the same thing. Okay, and slope, this is my input raster. I do have a zone which is watersheds. I'm going to calculate, say, the average slope within each watershed. Okay, so I'm going to assign the new value, average slope, within this to this polygon. Okay, so you actually will generate a polygon data layer. Okay, and another set of tools you're going to use a lot when you do raster analysis is terrain analysis. In our Pro, the toolbox, we actually have a tool set called surface analysis that's specifically for terrain. So the basic idea is you can only just have the elevation data layer, digital elevation data model, or DEM. You can use the tools to generate slope, aspect, terrain curvatures, okay, and many others, like how the sun illuminate our terrain surface. You're going to generate another data layer, secondary data layer called hue shade. Okay, so you can see you can generate a lot of data layers to characterize the terrain features. Okay, characterize your terrain, the attributes. So in our virtual lecture, I'm going to use a real example to show you how to do that. Okay. And another set of very commonly used tools is the hydrological functions. So in our ArcGIS toolbox, you have hydrology. That tool set can just take elevation, start from there. You will be able to generate flow direction. So given 1 pixel in your raster data layer, if you have a water, you have a river flow over that pixel, okay, and to which direction your water will flow. so that's called flow direction or flow accumulation. Say you are standing at certain pixel, and how many pixels, if they have water that can contribute to your pixel. Okay, that flow accumulation. And based on flow accumulation, you can also define your streams, because streams will be the pixel that have many pixels that can flow into that pixel. Right? Okay, and based on your streams, you can define your watershed boundaries. You can also define your watershed outlets. So this sounds a little bit abstract. In our virtual lecture, I'm going to use our Catalina Island, okay, a section of our Catalina Island to show you how to do this, okay, with ArcGIS, the toolbox. Okay, so after this lecture, you're going to answer those questions. Okay, let me emphasize this. Number one, why it's so convenient to use rasters to do your spatial analysis. Okay, that's because you have basic unit as cells. Basically, when you do the overlay, you just combine the cells. Your operation is based on the cells. Okay, so this is the main advantage. Then you need to understand the basic operations. Okay, like what is reclassification. Okay, how to overlay your different data layers. Okay, it's map algebra, right? Single cell to single cell, or you can combine the neighborhood information by using this neighborhood function. Okay, or your zonal function. Okay, and okay, how does each function work? Okay, and how to do terrain analysis and how to do hydrological analysis. Okay, so like our last lecture, vector analysis is very practical, so I hope you can join our virtual class meeting. I'm going to show you with the real examples. Okay, so I will see you on Tuesday and Thursday.